This is a video about kinetic energy. Kinetic energy, the kinetic part of it, just means there's motion. So kinetic energy is energy due to motion. And we can do that a lot of different ways. We can talk about the motion of particles in the air. We can talk about things spinning and rotating and vibrating and any number of things like that. But the big thing that we are worried about is going to be, for right now, straight line motion. If I've got straight line motion, if I've got a block like this with a mass of m and a velocity of v, then I'm going to have a kinetic energy that is half mv squared. This thing is going to have units of joules, where 1 joule is equal to 1 Newton meter. Mass, that's kilograms. I've got a meter squared per second squared, so kilograms meter per second squared, that's a Newton, times another meter is a Newton times a meter, that's a joule. A lot of textbooks, a lot of instructors like to stick with one letter for variable names. It makes all kinds of sense to do that, and in a computer programming standpoint, from a computer programming standpoint, that would make a whole lot of sense too. I think KE is a pretty convenient way to know that we are talking about kinetic energy, so I'm just going to use KE for it. You've got an intuitive feel for this already, at least to a certain point. If I have a ping pong ball moving at 10 miles an hour, that's going to carry some amount of energy. If I have a bowling ball moving at 10 miles an hour, that's going to carry more energy. There's some kind of a feel for how this thing works. Now, our regular kinetic energy equation, this is a translational kinetic energy, and it's just half mv squared. There's nothing fancy going on with that at all. I do want to give you an example or two of this, but I will do that in a separate video.